In this video, I will discuss the topic of standard form, also called scientific notation. First, let us understand what numbers expressed in standard form or scientific notation look like. Here we see on each line, numbers are rewritten in purple in standard form. Take a second. What can you identify about standard form? We see a couple things. There is always a single digit but not 0 before the decimal point. The number is multiplied by 10 to some power. This notation is very useful. At a glance, you can tell the size of a number. The more positive the index is, the larger the number. Positive indices indicate large numbers, negative indices indicate small numbers. Further, the larger the positive number, the bigger the number is. And the larger the negative number, the smaller the number is. For example, 3 by 10 to the negative 8, which is equal to 0.000000003. You are more likely to make a mistake when writing out all the zeros. As we saw in my video on multiplication by powers of 10, see description below. 5.1212 multiplied by 10 to the second power is equal to 512.12. The decimal point is moved 2 spaces to the right, and 4.7 by 10 to the 8th power is equal to 470 million. The decimal point is moved 8 spaces to the right. What about negative numbers? I didn't introduce those before. 1.6 by 10 to the negative 1 is the same as 1.6 divided by 10 to the positive 1 power. So we move the decimal point 1 space to the left. And 8.89 by 10 to the negative 5 is the same as 8.89 divided by 10 to the 5th power. So we move the decimal point 1, 2, 3, 5 spaces to the left. Some examples. 85 million, represent this in standard form. 85 million is equal to 8.5 and we multiply it by 10 to some power. The decimal point is moved 1, 2, 3, 4, 5, 6, 7 spaces. And this is a very big number, so we know that the sign is positive. 10 to the positive 7 or just 10 to the 7th power. And we can see that 8.5 multiplied by 10 to the 7, we'll move the decimal point 7 spaces to the right, and we'll get back the number we started with. A second example, 36. 36 is, we want one number before the decimal point that isn't 0. So we want to move the decimal point to here. We get 3.6. And we multiply it by 10, we move the decimal point 1 space. And it's a big number, so it's positive 1. We want one digit before the decimal point that isn't 0. So we want the decimal point here to get 1.0. There's nothing after the decimal point. We could use the placeholder of 0 if we like. And we multiply it by 10 to the decimal point is moved 1, 2, 3, 4 spaces. And this is a very small number, so we know that this is a negative 4. And as I said prior, multiplying by 10 to the negative 4 is same as dividing by 10 to the positive 4. So it's the same as moving it 4 spaces to the left. And a last example, 0.00000000091 in standard form is equal to, we want one digit before the decimal point that isn't 0. So we move it to here, 9.1. And we multiply by 10 to some power. The decimal point is moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It moved 10 spaces. This is a very small number, so we know that it's negative. And we could confirm 9.1 multiplied by 10 to the negative 10 is the same as 9.1 divided by 10 to the positive 10. We'd move the decimal point 10 spaces to the left, and we'll get back the number we started with. So this is correct. I am Mr. Dube. If you found this video useful, please like this video. If you are new to this channel, please subscribe. Join me in the next video.